Very good morning, dear students. I welcome all of you to the today's session. And this session, we are going to discuss about how to prepare a frequency distribution. In the previous class, already we have started discussion about how to draw a frequency table and also how to prepare a frequency curve or how to draw a frequency curve. Now, in this session, we are going to discuss about what are the preparations or how to prepare the frequency distribution. Already we have discussed about the frequency distribution. Here frequency distribution means classifying of raw data in a particular order. In that way, if we are going to distribute the frequencies in a proper order, what are the steps we need to follow or what are the preparations we must do in order to make a proper frequency distribution. In this case, to follow a proper frequency distribution, mainly we need to satisfy the four questions or we need to address a four questions before entering into a frequency distribution of any particular data. What are the main four questions or four steps we need to follow in the sense? The first and foremost important step for the frequency distribution is deciding the number of classes or what number of classes we should be had in the frequency distribution. And second main question is what should be the number of or size of classes. The second question is the size of class, and the third question is how should we decide the class limits. The third question is how should we decide the class limits, and the fourth important question while preparing the frequency distribution is how to decide the number of frequencies in the particular class. How to decide number of frequencies in the particular class. These are the main four questions or steps in order to prepare a frequency distribution. And relating to that, we will discuss one by one all these four steps to draw a frequency distribution. In that first one, first question is how many classes should we have? And the second main question is what should be the size of class? And the third main question is how should we decide the number of the class limits? And the fourth main question is how should we get frequency for each class? How should we get frequency of each class? These are the main four questions we need to address or we need to be answered before going to a frequency distribution of any particular data. In that first one, how many classes should we have for the frequency distribution? Here, if related to any particular data, before going to distribute any particular data, first and foremost important step is we need to decide how many classes or how many range of divisions we should have to classify the particular data. It means the number of classes first we need to decide. Before deciding the number of classes, before going to deciding the number of classes, first we need to know the variation in the values of a variable. Variation in the values of a variable. It means last class we have given one example for the raw data. The number of the marks scored by the 50 student in particular examination, that is economics examination. Take that particular data only for the example. First we need to observe the range of the values. Range of the values in the sense the lowest value and the highest value in the observation. The lowest value and highest value in the observation. That the difference between highest value and lowest value in the observation is nothing but range. By knowing the range of the values in a variable, we are able to decide the number of classes. It means how many classes we can be added to the frequency distribution. Before going to decide the number of classes or how many classes we should have, first we need to know the range of a values in a variable. Range of the values in a variable. And here the range means very simple, the difference between highest value and the lowest value of a distribution. Difference between highest and lowest value. Keep in your mind, range refers to difference between highest and lowest value is nothing but range. And in order to find out the range, we have a simple formula, that is range equals to, here range refers to the difference between highest, or we can also call that largest value and lowest value. The difference between largest and lowest value is nothing but range. And in order to find out the range, the formula is L minus S. L minus S. It means L refers to largest value minus the smallest value. Now for example, observe the raw data once, which I have given as an example. In that data, the lowest value starts from 0. Lowest value starts from 0 and the largest value starts from 100 and the smallest value is 0. In that particular raw data, the largest value is 100 and the smallest value is 0. Then largest value minus smallest value is 100. Then we got a range of the values. The value of range is between 0 to 100. The values are from 0 to 100. This is what range. By knowing the range, we are able to make a decision relating to number of classes. Here, after knowing the range of the values, before going to decide the number of classes, one more thing we need to decide, that is nothing but size of class interval. After knowing the range of the values, and also we need to decide the size of class interval. Also we need to decide size of class interval. Here in the last class itself we have discussed. What is class interval? Class interval is nothing but the difference between upper class limit and lower class limit of the particular class. The difference between upper class limit and lower class limit of the particular class. That's why to decide a number of classes, firstly we need to know the range of the values, and second mainly we need to know the size of class interval in order to decide the number of classes or how many classes we should have. Okay, and here if we want to decide the class interval, maybe the class interval will be vary from 5 to 15. We can take 5 as a difference between upper class limit and lower class limit, or we can take 10 differences between upper class limit and lower class limit, or we can take 15 as a difference between upper class limit and lower class limit. That is nothing but class interval. By deciding the class interval and range of the class, we have one formula to find the number of classes. What is that formula is? Formula is range. Range formula is L minus S divided by K. To decide the number of classes, we have a formula that is L minus S divided by K. Here L minus S is nothing but range. Range divided by class interval, we will get the number of classes. Are you understood? Range divided by class interval, we will get the number of classes. Here, now we have a range is 100. For example, we will decide the class interval or difference between upper class limit and lower class limit as a 10, because 10 is a reasonable limit between or difference between upper class limit and lower class limit for the clear cut presentation of a frequency distribution. That's why here we have decided class interval as a 10 and range is 100. Now keep it in the formula. The now range is 100 and K means size of class interval. We have decided class interval as a 10. Class interval as a 10. 100 divided by 10 equals to 10. Then number of classes are 10. Got it now? Now the number of classes are how many classes we should have means 10. Or you got it? Likewise, before going to decide the number of classes, firstly we need to know the range of a value in a variable. Range of the values in a variable or particular data, and after knowing the range, we need to decide size of the class interval. And with the help of these two particular concepts, we able to decide number of classes. In this way, we are able to decide the number of classes. Yeah, now this is how we can able to answer for the first one, to prepare the frequency distribution. Then we'll move to the next question. What should be the size of class? Okay, here to decide the size of class, in the same way in the first question and in the second question, always there is an interlink between these two. To decide the number of classes, firstly we need to know the size of a class. To decide the size of a class, we need to know the number of classes. These two questions are interlinked between each other. And here when we decide the number of classes, it is easy to decide the size of a class. Here number of classes are 10. We have decided number of classes are 10, and with the help of this number of classes, we can able to find a size of class. Now range is 100 and number of classes is 10 and class interval also 10, and we can able to decide the size of class is from 0 to 10 and 10 to 20, 20 to 30, 30 to 40 until we get a 100. Until we get a 100, the classes will be going to continue, and it means we will get 10 number of classes and each class size will be 10. Each class size, your size is nothing but what we will call class interval. Size is nothing but class interval. Here we have already decided class interval is 10 and number of classes is also 10. Have you got it? And the first two questions have satisfied. Now we will move to the third question. How should we decide the class limits? How should we decide the class limits? The third is, how should we decide the class limits? Here already we have discussed the class limit in the sense the two ends of the class are called as class limits. Here to decide the class limit we use one technique, is that always the lower limit or the smallest value in the observation. The smallest value in the variables or observation will be decided as a lower class limit of the first class. Always the lowest value or the minimum value of the observation will be decided as a lower class limit. Now for the example, in the raw data the lowest value is 0. Then the first class limit, the first class range lower limit will start from 0. The lower limit will start from the 0. Then how we will decide upper class limit? In the sense adding the size of size of class interval into the lower limit, we will get the upper class limit of that particular class. Adding the size of class interval to the lowest value, lower limit of the class. Here the lower limit we got it 0. Yes. Adding the class interval to the lower limit, we will get a upper limit. What is the class interval size? 10. Yes, right. We have decided here. The class interval size is 10. 0 plus 10. Then what will be the upper class limit? Then the upper class limit will be 10. Upper class limit we will get by adding the class interval to a lower class limit. By adding the class interval to a lower class limit, we will get upper class limit. Here the lower class limit is 0, class interval is 10, and 0 plus 10 we will get 10. Then next, this will be moved to a next class, and by adding the lower class limit, now lower class limit is 10, and class interval size is 10. 10 plus 10, 20. Then here we will get upper class limit as a 20. In this way, we are going to decide the class limits. Always the first class lower limit we will get through finding the lowest value in the observation and adding the class interval to the lowest value in the observation, or the lower class limit we will get a upper class limit. And here in the class limits we have two types, that is exclusive method and inclusive method. In the class limits we have two methods, one is exclusive method and one more inclusive method. Before that you understood the basics, right? Your basic is the class limits will always start the first class lower limit from the lowest value of the observation, and we will get upper limit of the first class by adding the class interval size to a lower class limit. By adding the class interval size to a lower class limit. Here lower class limit is 0, class interval size is 10. here how we got the lower class limit? By taking the lowest value from an observation. Understood, right? And here the class limits we are going to decide there are two types of class limits. One is exclusive method and one more inclusive method. Here class limits are two types or two methods. One is exclusive method and second one inclusive method. Here very simple exclusive method in the sense the first under the exclusive method or in the exclusive method the upper class limit of one class will be equals to a or will be moved to a next class as a next class lower limit. Upper class limit of one class will move to a next class lower limit or upper class limit of one class will be equals to the lower class limit of a next class. This kind of class limits we will be called as a exclusive method. Here in under the exclusive method upper class limit of one class is equal to lower class limit of next class. Are you understood? Under the exclusive method, the upper class limit of one class is always equals to the lower class limit of next class. For example, 0 to 100. Here lower class is 0, upper class is 10. And here the upper class limit of one class will move to a lower class limit of next class. And by adding the class interval to this lower class, we will get upper class. Again, this upper class limit will be moved as a next class lower limit. And adding the class interval to this lower limit, we will get upper class limit. Again, this upper class we are 20, and this upper class limit will be moved to as a next class lower limit. Adding the class interval to this lower limit, we will get upper limit, that is 30, and this class upper limit will be moved as a next class lower limit. And adding the class interval, the size of class interval we have decided 10. 30 plus 10 we will get upper class limit, that is 40. Again this class upper limit will move to a next class lower limit, that is 42. And 40 plus class interval we will get 40 plus class interval we will get 50. This is the method of exclusive under the class limit. And one more method we have to decide the class limit, that is inclusive method. Under the inclusive method, here the class limits, both the upper class limit as well as the lower class limit will be only the part of that particular class itself. Are you understood? The both upper class limit as well as lower class limit of the class, only the part of that class itself. It will not move to a next class. The upper class or lower class value will never move to the next class. the part of that class will be only that class itself. It will never move to a next class. Under this method, for the class limits are the part of that particular class only. That particular class only. It will never move to a next class. But in the exclusive method, the one class upper limit will move to a next class lower limit. Right now? But here, under the inclusive method, the both the class limits, whether it is in lower class limit or it is upper class limit, it will never move to a next class. That both the class limits will be part of that particular class only. It will never move to a next class. Are you understood? Here the one class upper limit will move to a next class lower limit, but in the inclusive method it will never move. The limits of the class will never move to the next classes. And here for the inclusive method you can take example 0 to 9 and 10 to 19 and 20 to 29, 30 to 39, 40 to 49. This is what example for inclusive method. Here you observe both lower class limit as well as upper class limit are excluded. They are not included to a next class, right? Both the class limits are the part of that particular class only. It will never move to a next class. Are you understood? Here there is no continuity between the classes. Both the class parts are the part of that particular class only. Are you understood? And this is what deciding the class limits. Whether if you want the continuity, we should have take a exclusive method. If you don't want continuity in the values, then we can take a inclusive method. Here, if we have an inclusive method of data, it is impossible to analyze or understand further. If you want to understand or if you want to go a further clarification, this inclusive data we should convert into a exclusive way. How should we convert this inclusive method of data into a exclusive method that we will discuss now. Yeah, now we have discussed about how to decide the class limits. There are two types of class limits. One is upper class limit and second one, we have two types of class limit. One is exclusive method and one more inclusive method. Here we have taken example for inclusive method. The class limits is 0 to 9, 10 to 19 and 20 to 29, 30 to 39, 40 to 49. Here we don't have continuity between the classes. For example, if we have a value like 9.5, whether we should include it into this particular class or we should include it into the next class, we will have a confusion, right now? That's why if the class limits are in inclusive method, it is unable to make a proper frequency distribution. That's why we need to convert the inclusive method of class limits into a exclusive method. We need to convert or we should make adjustment in the class interval. To convert the inclusive method of class limits into the exclusive method of class limit, there are four steps. Convert inclusive into exclusive method. Exclusive method. There are 4 steps. What are the 4 steps? Is first one, we need to find out the difference between find out difference between upper class limit of first class and lower class limit of next class. Understood? To convert the inclusive method of data into a exclusive method, there are 4 steps. In that first one, find out the difference between upper class limit of the first class and lower class limit of the next class. What is the upper class limit of the first class? 9. The upper class limit of the first class is 9 and lower class limit of the next class or second class is 10. Have you understood? The first class upper limit and next class lower limit difference we need to find out first. Are you got it? 9 minus 10, we got it 1. This is what difference between upper class limit of a first class and lower class limit of a next class. This is what the first step. And second step, divide. And now divide difference of time by 2. What is the difference we have of time? In the first step, the difference we got it 1, and this value 1 we should be divided by 2. Got it? What is the difference we got in the first step? That value or the difference we need to divide it by 2. Got it? Now what is the difference we got it? 1. When we divide it by 2, we get 0.5. We get the difference or the value is 0.5. And this 0.5 we need to subtract from the upper class limit and we need to add for the lower class limit. Have you got it? Whatever the value we got it, we should be subtract from upper class limit and we should be add to a lower class limit. These are the next 2 steps. The value of time from upper class limits of all the classes. First, third main step is we need to subtract the value of time from the second step. From the second step, what is the value we got it? 0.5. This 0.5 we need to subtract from the upper class limit of all these classes. And next, add the value of time from lower class limits of classes. This is what the 4 main steps in order to adjust the class interval or to convert inclusive into a exclusive method. Are you got it? First we need to find out the difference between upper class limit of a first class and lower class limit of a next class. That is, for example, we have taken 0 to 9 is the first class and 10 to 19 is the second class. The first class upper limit is 9, second class lower limit is 10. Then difference is 1. And what is the difference value we got it? That value we should be divided by 2. And while dividing 1 by 2, we will get 0.5. This obtained value is 0.5. This value we need to subtract. It means we should minus from all the upper class limit and we should add to each lower class limit of the all classes. Then we can able to convert into the exclusive method. Take example now. We will apply all these 4 steps now to a converted exclusive method. This is what? Inclusive. To convert into a exclusive class limit, we have already found all this value is 0.5 and here we need to add 0.5 to all lower class limits. Got it? Now 0 plus 0.5, the answer will be 0.5 and we should subtract 0.5 from all the classes upper limits, right? Then 9 minus 0.5. Once again, clearly you need to understand this. Find out the difference between upper class limit of the first class and lower class limit of the next class. And after finding the difference value we should be divided by 2. And after this, by finding this value, we need to subtract the particular value which we obtained from the lower class limit. Got it? Here we need to subtract the value from a lower class limit and we need to add the value obtained to a upper class limit. We need to subtract from lower class limit and again we need to add to a upper class limit. Now lower class limit is 0. Then now we need to subtract from the lower class limit. 0 minus 0.5, there will be a 0.5 it will start minus 0 means it will be considered 0 only. And add this 0.5 to a upper class limit, then 9.5. Again subtract 0.5 from the lower class limit means 9.5 and add to a 0.5 to upper class limit means 19.5 and subtracting 0.5 from the lower class we will get 19.5 and 29.5. Again 30 minus 0.5 we will get 29.5 and adding the 0.5 to a 39 we will get 39.5. 40 minus 0.5 we will be have a 39.5 and here 49 plus 0.5 49.5. This is how we are going to convert this inclusive method of class limits into a exclusive method. We need to find out the difference between upper class limit and next class lower class limit, and that difference value we should be divided by 2 and what is the value we will get, that value we should be added to a upper class limit and that value we need to subtract from the lower class limit. Have you got it? First we need to find out difference and what difference we will get, that difference value we should be divided by 2 and after that what is the value we will get? That value which we obtained or we got, that value we should be subtract from the lower class limits and we should be add into a upper class limit. Then we are able to convert the data into a continuous format. Understood? This is to decide the class limits. And next, one more important to prepare the frequency distribution is finding the number of frequencies for the each class, or how to find out the number of frequencies for each class, in the sense the values which will be appear between the particular class, we should make a tally marking. After the tally marking, we should be adding to a frequency. This is to prepare the frequency distribution. There are mainly four. First one, how to decide the number of classes. Second one, what should be the size of class. And third one, how to decide the class limits. And fourth one, finding the frequencies for each class, or how to find out the frequencies for each class. Here, how to find out the frequency means the values which will be appeared in the data in a particular class, we should be make tally marking, then we should add it to a frequency. Got it? And thank you everyone for listening this class.